Hi, my name is Miss Townsend. I love math. Let's do some math together. In this video, we're going to be solving absolute value inequalities. There's an absolute value inequality. Obviously, it's got both an absolute value with x inside of it, and instead of an equal sign making it an equation, it's an inequality. So the way we solve it is we do what we do algebraically with absolute value signs, which is we rewrite this as two different equations. And then we just use our inequality solving abilities to get two different inequality solutions. And then we have to bring them together. Let's just do the math. This isn't intended to be learning how to do it. This is just practicing with you. So the first thing I'm going to do is rewrite this as two different equations. The first equation is simply replacing the absolute value signs with normal brackets, and then I'll go from there. And the second equation is replacing the absolute value stuff with bracket, but inserting that negative in front to represent what the absolute value signs would do if I had a negative value with 3x plus 1. So now I just have two distinct inequalities to solve. So let's solve them. So this is just 3x is less than 8. So 3x, oops, nope, I could divide by 3. So x is less than 8 over 3. So I'll leave that for a second, come over here. So this time I'm going to divide by -1 first. So I'm going to divide by -1. Now remember, when you divide by a negative, the inequality sign flips the other way. So this becomes -9 because I divided by a negative. And you notice the inequality sign is now pointed the other way. So 3x is more than -10. Oh, my pen just went crazy. 1 second. So 3x is greater than -10. X is greater than -10 over 3. So we have to bring our answers into one answer, and we want interval notation. So let's visualize on a number line what our answers are doing. So boom. There is a way to draw with a ruler, but whatever. So one answer I have is -10 over 3. And I know that x has to be greater than -10 over 3, but not equal to. So that would be an open circle pointing in that direction. So that represents this solution right here. X is bigger than, but not equal to, -10 over 3. I had got another solution involving the number 8 over 3. Oops. And we know that this solution is x is less than that. So, hold on. There, now I have room to write. So that would again be an open circle and less than that. So the answer is actually all of the numbers between -10 over 3 and 8 over 3, but not including them. So I would write x is an element of round bracket, -10 over 3, 8 over 3, because it's all the numbers between. If you wanted to write your answer in set notation, you would say that -10 over 3 is less than x, which is less than 8 over 3. But I like interval notation for a question like this. That was good. Oh, you want to do another one? Excellent. Let's do one more. There we go. What fun we're having. So again, it's an absolute value inequality. And so we need to, first of all, break that into two distinct equations based on what's happening with the absolute value sign. And I'm just going to say you are more than welcome to add 2, like move the 2 over because it's not part of the absolute value as a first step. I'm not going to just because my brain doesn't want me to do that because, I've sort of trained myself to always do this step first so that I don't forget to do this step. But obviously there's nothing wrong with it. So that is the first equation. Again, I've just rewritten the absolute value signs as a normal bracket and everything else stayed the same. And then the second equation I need to create is the one where I basically do the same thing, but there has to be a negative sign introduced in front of that absolute value bracket. So now I'm going to try to do this math. So 3x plus 1 over 6. I'm going to add 2 to the other side. So I get that. I'm going to multiply by 6 to get 66. I'm going to subtract 1. And then I'm going to divide by 3. So I just get x not equals. Who wrote equals? X must be greater than 65 over 3. So notice that I didn't have to switch the sign ever because at no point did I multiply or divide by a negative. So now let's look at the other one. So negative 3x plus 1 over 6. So I just prefer to see it like that. And again, I'm going to add 2 to the other side. So I get 11. So now I'm going to multiply by 6 to get 66. Now I'm going to get rid of that negative sign. There's lots of different orders you could do it in, right? Like we know enough algebra. This is just how I like to do it. I'm going to divide by that negative 1. So this becomes a negative 66, and the sign flips the other way. So now I'm just going to continue solving. I'm going to subtract 1. So I get x is less than negative 67 over 3. So again, I want to make sure that I think about these two problems together and then write my answer in set notation. There's a ruler. I'm not going to use it. I don't know how to use it. I just write on this whiteboard. Nothing fancy here. Clearly. Okay, so 65 over 3 and negative 67 over 3 is here. So I always like to look at the left number first. X is supposed to be below that. So that means that it's not equal to it, but it's allowed to be below that. Then I had another answer, which was x, here's 65 over 3. So I need to be greater than that. So open circle and greater. So this is not my answer is not between two numbers like it was on the first question I did, but rather it's these two distinct intervals. So in interval notation, we would say that x is an element of, so the left side, so this arrow goes from all the way over at negative infinity, which is somewhere over there. Actually, it doesn't exist, but you know, it's fun to think about it. So all of the numbers between negative infinity and negative 67 over 3 would satisfy this original equation. And also, union symbol, ooh, really messed that up. All of the numbers that start at 65 over 3 and go up to infinity. And rounded brackets, because always rounded brackets for infinity, and these are open circles, so those roots are also not included. Right, I hope that was helpful. Let's keep doing math, but maybe offline.